Okay, on number 19, we are going to be working with a related rates problem with a cone. And so the first piece of information that they've given me is that the water is running out at 2 cubic feet per minute. So let's write that down real quick. And remember that when we talk about cubic feet, that means that we're talking about volume. And on the bottom, we're talking about time. So what we have here is the rate of the volume in a certain amount of time. All right, then they tell me, let's draw a picture of a cone here, that the radius at the top of the cone is 5, and that the height of this cone is 10. And so I'm going to use that in just a minute to set up a proportion. And so the radius is to the height as 5 is to 10. And I'm going to solve for that in just a minute, but let's see what we're looking for first. Okay, I want to know how fast is the water level sinking. Okay, so here's my water level right here. So I'm trying to find dH dt when it is 4 feet deep. So when we have a height of 4 feet, we want to know what is the rate of that height that's changing. Okay, so my formula that they have given to me is 1/3 pi r squared h. Okay, so what I'd like to do is I'd like to get this down to where it just has one variable in it besides the volume over here. And so I am solving for h, which means that I'd like for everything to be in terms of h. So let's solve over here for r. So I'm going to say that 10r is going to be equal to 5h. And so r is going to be equal to 5 over 10, or 1/2 h. And now I can plug that into my volume formula. That's not going to change, so I can go ahead and plug that in right here. And now I've got everything on the right-hand side in terms of h, which is going to be really helpful. All right, let's take that and square it. So when I square my 1/2, I get 1/4 h squared, and then I still have an h that I'm going to multiply by. So my volume formula now is 1/12 pi, or let's go ahead and make that pi over 12. Pi over 12, and then h squared times h gives me h cubed. All right, so that's going to be a lot easier to take the derivative of. I don't have to use a product rule now, so I'm going to bring my 3 to the front. Let's start with our dv dt over here. And now I'm going to bring my 3 to the front and multiply, and that's going to give me pi over 4 h squared. And then I'm going to have dH over dt. It's okay. Okay, so now let's fill in our given information. So I know that dV dt is 2. I've got my pi over 4 right here. I know that h is also 4 squared. And then dH over dt is what I'm looking for. Okay, so this is going to give me 2. I've got 16 right here, divided by 4 gives me 4 pi, right there, dH over dt. And without a calculator, I'm going to say that dH over dt is going to be equal to 2 over 4 pi, or 1 over 2 pi. Either answer is fine. And we are working in feet per minute. Okay, on number 20, we're looking at an implicit differentiation problem. So on number 20, we are working with y squared plus xy minus x cubed equals 8. Don't forget about the product rule that you have right there when you go to take the derivative of that. So these two things are being multiplied together. Okay, so when I take the derivative, which is what they're asking me for in part A, this is going to give me 2y. And since we're working with implicit differentiation, every time I take the derivative of y, I need to include a dy over dx. All right, now I want to use my product rule with this. So here's f and here's g. So I'm going to have g times f prime, which is 1, plus f, and then g prime, which would be 1, dy over dx. And then I'll have minus, and the derivative of x cubed is 3x squared, and be careful right here, the derivative of 8 is 0. Okay, so I'm going to keep everything that has a dy dx over here on this side, so that's 2y dy over dx, and x dy dx. And I'm going to move everything that doesn't have a dy dx over to the other side. So I'm going to subtract over my y and add over my 3x squared. So that's going to give me 3x squared minus y. Now I can take this dy dx out like a common factor. If you want to go through this step right here. So that's going to be 2y plus x. And I'm trying to get dy over dx by itself. So these are held together with multiplication, so I'm going to divide. So I'm going to say that dy over dx is equal to 3x squared minus y over 2y plus x, or x plus 2y if you prefer. Okay, so that's what it asked me for on part A, is to find what dy dx is equal to, or find the derivative. Okay, on part B, it wants me to evaluate that at the point 2, negative 4. Okay, so there's my dy over dx. So on part B, I'm going to work with 2, negative 4. All right, so plugging into that, dy dx is going to be equal to 3 times 2 squared minus negative 4 over 2 times negative 4 plus 2. Let's make that a plus right there. So 2 squared gives me 4 times 3 gives me 12, plus 4 gives me 16. And on the bottom, I'll have negative 8 plus 2 gives me negative 6, and so that will reduce down to negative 8/3. Okay, so what we've just found right there is the derivative at this point. Now remember that a derivative is the same thing as a slope. So in part C, they ask me to write the equation of a tangent line. So let's write down our formula for the equation of the tangent line. Looks like this. And they've given me the point 2, negative 4. And using that point, I found the derivative, which is the slope, to be negative 8/3. So here's x1 and y1. And here's my slope, and I just need to plug them in. So y plus 4 minus negative 4 is equal to negative 8/3 times x minus x1, which is 2. And you can leave it just like that. In a free response question and a multiple choice, you may need to solve for y, depending on what your answer choices look like. Okay, number 21, we're talking about the motion of a particle here. We're moving along a horizontal line, so they've given me this formula to work with, t cubed minus 12t squared plus 36t plus 7. All right, on the first one, they want me to find the velocity of the particle at 5 seconds. So to find the velocity equation first, I'm going to take the derivative of my position. This is my position right here. Okay, so the derivative of that is going to give me 3t squared minus 24t plus 36. And now I want to find out what that is in 5 seconds. That's going to give me 3 times 25 minus 24 times 5 plus 36. So it's going to give me 75 minus, go over here on the side for just a minute, 24 times 5, that gives me 20. So that's going to be 120 plus 36. Okay, so 75 minus 120 is going to give me negative 45, and 36 is going to give me negative 9. And they told me that I'm working in meters, so that'll be in meters per second. Okay, since that is negative, that tells me that that horizontal movement is going to the left, by the way. Positive to the right and negative to the left. Okay, in part B, they ask me to find when the particle is moving to the right. So first I need to know where I have a place where it is at rest. Okay, so I want to find out where that velocity, that 3t squared minus 24t plus 36, where is that equal to 0? All right, let's take out a 3, so this will be a little bit easier to work with. That's going to give me 8t, and this is going to give me 12. And I'm going to factor that. Okay. That will give me t, and my factors of 12 that will add to give me 8 are 6 and 2. So I'm going to have my particle at rest at 6 seconds, and at 2 seconds, and that tells me where this thing is equal to 0. So let's put my 2 and my 6 on the number line. Okay, and let's pick some numbers that are around this. So I'm going to start at 0. We're talking about time here. And I'm going to plug in right here to my velocity equation. You can plug into this one as well. And for this one, since I'm doing 0, that would be 0 and 0, which gives me positive 36. So here I'm going to have a positive area. I'm going to work with 5 in between here, since I already know that the velocity at 5 is negative. And then finally, I'm going to work with 7 up there above my 6 seconds. And I'm going to plug it into my factored form because that'll be easier. So positive 3 and 7 into here gives you a positive, and 7 into here gives you positive 5, so that will be positive. So this particle, it asked me where the particle is moving to the right. So this particle is moving to the right between 0 seconds and 2 seconds. And also from 6 seconds into infinity. And I know that, it tells me to justify my answer, I know that because the velocity is positive. So velocity positive means it's moving to the right, and negative means it's moving to the left. Okay, on part C of this same question, it asked me to find the acceleration. So I already know that the velocity is 3t squared minus 24t plus 36. To get the acceleration, I'm going to take the derivative of that. So the acceleration is going to be 6t minus 24 plus 0. All right, and I want to find this acceleration at 5 seconds. Okay, so 6 times 5 minus 24 gives me 30 minus 24, which gives me 6 meters per second, or per second squared. Okay, and finally in part D, it asked me, is it speeding up or slowing down at 5 seconds? So remember that you'll have a particle that is speeding up when the velocity and the acceleration have the same signs. And you'll have a particle that is slowing down when the velocity and the acceleration have opposite signs. Okay, so we found our velocity at 5 seconds, at 5 seconds to be negative 9 meters per second. And we found the acceleration at 5 seconds to be positive 6 meters per second squared. So since this one is negative and this one is positive, I know that at 5 seconds, the particle is slowing down. They have opposite signs, therefore this particle is slowing down. Okay, if I give a reason for your answer, this right here is perfectly fine. We have that slowing down is because the velocity and the acceleration have opposite signs. Okay, on number 22, we're working with a function. The f at 1 is equal to 4, and on the graph, the slope is given by that equation right there. Okay. So our slope, remember, is the first derivative. So let's start by writing down that what they've told me there is that the first derivative is 3x squared plus 1 over 2y. Okay, and by telling me that f at 1 is equal to 4, they've given me a point 1, 4. So when x is 1, y is 4. Okay, and in part A, they want me to find the slope of the graph where we have x equal to 1. All right, so I want to find the derivative or the slope at 1. So I'm going to plug in 1 for x, and I'm going to plug in 4 for y, since they told me that that's what y is equal to. So 1 squared gives me 1 times 3 plus 1 gives me 4 over 8, which gives me 1/2. So we have a slope of 1/2. Okay, that was part A. And then in part B, they asked me to write an equation for the tangent line. So part B, my equation for my tangent line we will use this formula here, and this is my slope, and this is my x1 and my y1. So that will give me that y minus 4 is equal to my slope of